Assalamu alaikum students, how are you? Today our topic is high and low, loud and quiet sounds. In this photograph we can see there are two singers. This boy sings louder than this girl, and he makes vibrations bigger in the air than she. However, she can sing higher notes than he can, and she can submit more sound waves every second than he can. This is the comparison between their sounds. And then our next topic is pitch and frequency. The pitch of a sound means how high or low the sound is. It depends upon how rapidly the sound producer vibrates. Pitch is measured by frequency. The frequency of a sound is the number of sound vibrations set up in 1 second. It is measured in hertz. For example, when you pluck the top string of a guitar, it vibrates 660 times a second. It means that its frequency is 660 hertz. But when you pluck the bottom string, it vibrates only 165 times a second. It means its frequency is 165 hertz. The higher the frequency of a sound, the higher is its pitch. अच्छा बेटा पिच ऑफ द साउंड से मुराद है कि जो साउंड है कितनी हाई या लो है, और साउंड का हाई या लो होना डिपेंड करता है कि हाउ मैनी टाइम्स द साउंड प्रोड्यूसर वाइब्रेट्स, यानी वाइब्रेशन ऑफ द साउंड प्रोड्यूसर इस पर डिपेंड करती है पिच। और इसको हम फ्रीक्वेंसी कहते हैं कि फ्रीक्वेंसी इज़ द नंबर ऑफ वाइब्रेशन सेट अप इन 1 सेकेंड, और उसकी यूनिट है हर्ट्स। और अगर आप गिटार का जो ऊपर वाला स्ट्रिंग है उसको आप वाइब्रेट करते हो और वो 1 सेकेंड में 660 टाइम्स वाइब्रेट होता है, तो इट मीन्स कि उसकी फ्रीक्वेंसी 660 हर्ट्स है। और अगर आप उसका बॉटम स्ट्रिंग वाइब्रेट करते हो तो 1 सेकेंड में 165 टाइम्स वाइब्रेट होता है, तो इट मीन्स उसकी फ्रीक्वेंसी 165 हर्ट्स है। इसका मतलब है कि जितनी हायर फ्रीक्वेंसी होगी उतनी साउंड की पिच जो है वो भी हाई होगी। ह्यूमन ईयर ऑडिबल फ्रीक्वेंसी रेंज इज 20 to 20,000 hertz. Sounds above 20,000 hertz are called ultrasounds, and ultrasounds are used in hospitals for breaking down kidney stones and gallstones without the need of surgery. Ships use ultrasounds in echo sounders to measure the depth of the water. Animals such as bats and dogs can detect ultrasounds. Sounds whose frequency is below 20 Hz are known as infrasounds, and infrasound is used to monitor earthquakes and study rock formation. It can be detected by some animals such as whales, elephants, etc. बेटा जो ह्यूमन ईयर की ऑडिबल फ्रीक्वेंसी रेंज है वो 20 हर्ट्ज से लेकर 20,000 हर्ट्ज तक है, और ऐसी साउंड्स जिनकी फ्रीक्वेंसी 20,000 हर्ट्ज से ज़्यादा होती हैं उनको हम अल्ट्रासाउंड्स कहते हैं। अल्ट्रासाउंड्स जो है ये हॉस्पिटल्स पे किडनी स्टोन्स और गॉल स्टोन्स को तोड़ने के लिए इस्तेमाल होती है, ताकि सर्जरी के बगैर ही इनको साउंड से अल्ट्रासाउंड से उनको ब्रेकअप कर दिया जाता है छोटे छोटे पीसेस में। तो फिर फाइनली किडनी के जो स्टोन होते हैं वो यूरिन के ज़रिए पे बाहर आ जाते हैं, और इस तरह सर्जरी के बगैर ही उन स्टोन्स जो हैं वो उनका ट्रीटमेंट कर दिया जाता है। और शिप्स जो हैं वो भी अल्ट्रासाउंड यूज़ करती हैं पानी की डेप्थ मेजर करने के लिए, जो इको साउंडर इस्तेमाल करती हैं उसमें। और ये बैट्स और डॉग्स जो हैं वो अल्ट्रासाउंड्स को डिटेक्ट कर सकते हैं। और ऐसी साउंड्स जिनकी फ्रीक्वेंसी 20 हर्ट्ज से कम होती है उनको इंफ्रासाउंड्स कहते हैं, और ये यूज़ होती हैं अर्थक्वेक को मॉनिटर करने में, रॉक्स की फॉर्मेशन को स्टडी करने में, और वेल्स, एलिफेंट्स वगैरह इनको डिटेक्ट कर सकते हैं। Our next topic is loudness and amplitude. The loudness of a sound depends on height of the sound waves called amplitude. The greater the amplitude, the louder the sound. This can be measured in decibels. And this is the sound wave. Sound is represented in the form of waves. These highest points are known as crest, these lowest points are known as trough, and wavelength, in this case the wavelength is the distance between two consecutive crest और consecutive trough. क्लियर? तो जो लाउडनेस है साउंड की वो डिपेंड करती है एम्पलीट्यूड पे. एम्पलीट्यूड क्या है? एम्पलीट्यूड इज़ द height of the wave. This is the height of the wave, this is the amplitude, and the loudness of the sound depend upon amplitude. But the next topic is seeing sounds. We cannot actually see the sounds, but with the microphone connected to an oscilloscope, we can show sound waves as waves on a screen. This is the oscilloscope, and microphone is attached with this oscilloscope, and when sound waves enter the microphone, the vibrations are changed into electrical signals like this, and the oscilloscope uses these to produce a wavelength. But this sound is louder than this sound because we can see that its amplitude is large as compared to the amplitude of this wave. And this sound has higher pitch or frequency as compared to this sound, as we can calculate that the number of vibration produced per second is greater in this case as compared to this. The next topic is the wave equation. The relationship between the speed, frequency and wavelength of a sound can be shown by this equation. Speed in meter per second is equal to frequency in hertz multiply wavelength in meter. For example, the speed of sound in air is 330 meter per second. Using the above this wave equation, sound waves with a frequency of 110 hertz have a wavelength of 3 meter. We can calculate this by putting this value in this formula. Next we have to do test yourself. Question number 1. What is meant by part A, pitch? The answer is the pitch of a sound means how high or low the sound is. It depends on how rapidly the sound producer vibrates. Pitch is measured by frequency. Question number 1, part B, the frequency of sound. The frequency of sound is the number of sound vibrations set up in 1 second. It is measured in hertz. Question number 2, the frequency of a drum note is 20 hertz. What does this tell you about the drum skin movement? The answer is the frequency of a drum note is 20 hertz. It means skin of the drum vibrates 20 times in 1 second. Question number 3. A drum is hit hard and then softly. Part A. How does the volume change? When the drum is hit hard, a loud sound is produced, mean high volume. And when it is hit softly, a quiet sound is produced, mean low volume. Question number 3, part B. How does the amplitude change? Beta, the answer is when the drum is hit hard, the skin of the drum vibrates with high amplitude. When it is hit softly, the amplitude of vibrations are smaller. Question number 4. What is the wavelength of a sound with a frequency of 330 Hz? Take the speed of sound in air to be 330 meter per second. Beta, the answer is we have to apply the formula speed in meter per second is equal to frequency in hertz multiply wavelength in meter. Wavelength in meter is equal to speed in meter per second divided by frequency in hertz. Frequency is 330 hertz, speed is 330 meter per second. Wavelength in meter is equal to 330 over 330 is equal to 1 meter. Thank you.